We begin tonight with that crime alert. Thieves caught breaking into a home in the middle of the day.
This is surveillance video of the bad guys in action, scoping out the house before then breaking into a door to get inside.
I already had a break-in 2 months ago. I was already kind of hyper-vigilant about it.
It happened before, in September, he says. In fact, that's why outside the townhouse there's the ADT sign. Also, he installed cameras that cased the place. Apparently not enough of a safeguard to ward off these two.
So as an overview for our project basically focuses on enhancing home security specifically for elderly individuals. This is by utilizing IoT technology to create a user-friendly and also the automated security system. This project is using sensors to detect and monitor theft activities where it is applicable among elderly work, thus being user-friendly as well. So there are three key features that implemented in this project, which is the first one, the automated monitoring, which it continuously monitors the status of the sensors. Number two is the real-time alerts, which it sends instant notification via Telegram when security breach is detected. Last but not least, the real-time data visualization, which is it provides a clear and easily a dashboard via Streamlit for monitoring system. So the project significance is that first it addressing elderly needs, which it simplifies security system operation and visuals for elderly users, and provides immediate and clear alerts for potential security threats. It also supports independent living with reliable security measures. In terms of the technological benefits, this project is where we integrate IoT to become part of the system for our project. So it utilizes advanced IoT technology for efficient security solution. It also ensures real-time alerts and updates for quick responses. And last but not least, it adapts to specific needs and preferences suitable for various environments. And in terms of broader impact, we want our project in the future to apply more sensors and functionalities so that it can be used for larger scale projects.
For problem statement and objectives, let's first look at the system, which is smart and sound wireless security system for elderly. Elderly struggle with complex security system, limiting independent living, and this project proposed automated, user-friendly, smart home security solution in order to help with increased home security. For problem statement, number 1, elderly individuals often find it challenging to use complex security system. Number 2, traditional security systems don't efficiently detect unauthorized entry, leading to delayed responses. Number 3, security breaches need immediate attention, but existing systems fail to provide real-time alerts to users. Number 4, elderly users need a clear and understandable way to monitor their home security status. And number 5, ensuring the safety and independence of elderly residents require a reliable and straightforward security solution. We have 5 objectives. Number 1, able to create an automated user-friendly smart home security solution. Number 2, able to develop a system that uses image sensor to accurately detect unauthorized entry or housebreak. Number 3, able to implement a notification system. Number 4, able to use Microsoft Azure to create a user-friendly dashboard. Number 5, able to design a system that enhances safety and independence for elderly residents.
So I'll be presenting the system flowchart. So first we have the initialization of the Telegram bot and all the load all the data. So this is just basically to start off the Telegram bot chat and also to load all the authorized users' IP addresses. So next the user will receive the data, receive a message. So if the user is registered, then it will move on to the next step. If not, then the unauthorized user will go through a series of registration, and the main user will approve or disapprove of the user. And if the user is rejected, then it will get a notification status. So after all of that, it will go next to the process to user command based on current state block. So basically what this means is it will ask the user what it wants to do, whether it wants to check the dashboard or it wants to set up the sensor for the calibration, for the sensor's calibration and everything, just to check how far they want the detection or not, how many voltage, etc. So next, the sensor will then continue to read data, and it will do that on a continuous loop. So if if there is some sort of movement, then there will be an alert sent. If not, then the loop will keep on going. So it will send an alert to Telegram, and also send the data to Microsoft Azure for visualization. So if the user determines that it is safe, then all the readings will stop and also the alert will stop. If not, then the alert will continue. So next here we have the system block diagram. So first we have the Raspberry Pi, the main board, connected to the sensor and also the MPC3008. The sensor is a MH infrared line tracking sensor, and the MPC3008 is an analog to digital converter because the sensor can only send analog signals, and the Raspberry Pi can only read digital signals. So then we have a few inputs there: the mouse, the keyboard, and also the power source, which is very important to power the Raspberry Pi, and for the monitor to just access the Raspberry Pi OS. And then lastly, we have the mobile phone to communicate with the Raspberry Pi.
This is our prototype where we use MH sensor replacing the initial ultrasonic sensor because the value is not constant, and we use MCP3008 ADC because Raspberry Pi can read analog values directly from the sensor.
So this is the result of Telegram bot that we have created and running for our device. So you can see that setting up our device actually as easy as 1, 2, 3. Because why? Because first you just have to register as a user through our secure Telegram bot, and then you have to install the sensor at the desired location, of course at your door or your window, and lastly you're just left with to calibrate with just a tap. So we never mentioned that we actually offer a two unique tier security approach, which is, you can see there is a main account for full control and administration, and we also have a secondary account for monitoring and peace of mind. So what are the features that we offer you? So first, we also offer you a simple registration process with admin approval for added security, which is a two-tier system, and we also give you a quick sensor calibration, and you also can get an instant break-in alerts, and also you just can cancel the break-in alert with just a one-touch safe confirmation. So real-time monitoring, that's also important for our device. Whether you are at work or away, our device keeps you connected because you can just receive an instant alerts, and also you can see the dashboard of the live monitoring sensor.
So here we have a Wireshark analysis for the Telegram and also towards the Raspberry Pi. So from this we can see there is a connection pair between the two IP addresses, which is 172.29.70.164, which is the Raspberry Pi, and 191.108.56.186, which is the Telegram. So we can see that the Telegram has a port of 443, which is a very common HTTPS port for any sorts of social media, and the Raspberry Pi has a port of 51100. So we can see that there is a handshake process going on. You can see there is SYN and SYN/ACK, basically showing that there is a three-way handshake process. But we can only see the PSH and ACK flags, which are used to push the data to the receiving end, which is to the Raspberry Pi. So here we can also see a little bit more. We can see that they are using a TLS for secure communication, ensuring that data transmitted between the Raspberry Pi and the Azure IoT is encrypted and protected from eavesdropping and tampering. And there's also a little bit of network reliability also. The use of TCP keeps alive packets indicates an effort to maintain a reliable connection, essential for IoT devices that require continuous and stable connectivity to cloud services.
This is using Trimlit, where we were able to get the output, but we encountered some errors and had some issues integrating it with the overall project.
So why are we using Microsoft Azure instead is because we found out that the Microsoft Azure is really supports varieties of libraries which are required for our project. So for Microsoft Azure dashboard development, we just need to have three important things, which are the scope ID, and the device ID, and the primary key. So this system basically it can adopt to any other users by changing these three items according to the device. And to design the layout also, it has some template already available. We just need to assign the variable that need to be observed during the process.
So here's Wireshark analysis on the Azure website. So here the first thing we can see is that there's a communication between the two devices. The Azure website and also the Raspberry Pi. So the packets shown are primarily TLS version 1.3. So it's handshaking between the Raspberry Pi and the Azure IoT Central Server, which is our server, as you can see from the filter that we looked for our server as well. So the IP address is 172.20.10.12 for the Raspberry Pi, and the IP for the Azure is 13.107.6.158. So you can see there is a handshake process going on. As you can see, there are multiple client hellos, which indicate the start of the TLS handshake process from the Raspberry Pi to the Azure server. And then we can also see like a few details, like the source port is 60046 for the Raspberry Pi and 443 for Microsoft Azure. As mentioned before, it is a very common thing used port for the internet most of the time. So yeah, it just keeps on sending data to one another.
Next is complexity and limitation. For Streamlit, its complexity is deployment process can be tricky. App development requires coding from scratch and library issues. Its limitation, highly customized and complex UI components might require additional HTML, CSS, or JavaScript, and it is for small to medium-sized application. For Azure, the complexity is highly versatile but also requires knowledge of Azure ecosystem. And limitation, Azure service can be expensive and number of users are limited.
Okay, so now I'll be presenting the outcomes and future directions of our IT security system project for elderly users. First, let me highlight our key achievements. First of all, we have successfully developed a user-friendly IoT security system tailored specifically for elderly users. This addresses a critical need in our aging society. And then, our system actually implements a real-time alerts via Telegram and utilizes Azure database for data visualization, ensuring that users and their caregivers stay informed and can easily interpret for the data. And actually, you can also, instead of caregivers, we can also give this device to a police department or maybe the local security guards or actually the neighborhood. Why? Because Telegram bot actually can create a group and put everyone that involved inside the same group, so that when there is an alert sending to the Telegram bot, it's actually also sending to the same group, which notifies everyone in this case. Yeah. And then most importantly, we also have addressed the crucial need for simplified security that enhance elderly independence. Our goal was to provide peace of mind without compromising autonomy, and I believe we have achieved that balance. However, every project faces challenges and ours was no exception. We encountered some integration issues with Streamlit, which we are actively working to resolve, but we are instead using Azure to replace the Streamlit. Now, looking to the future, we have several recommendations to enhance our system. First, we propose adding a vibration ring to alert users during break-ins. This tactile notification could be crucial for users with visual impairments. To address hearing impairments and increase overall safety, we recommend incorporating a buzzer or alarm. This would not only alert the elderly residents but also notify the neighborhood in case of an emergency. Now, to ensure our system truly meets the need of our target users, because we want the best for you, we suggest conducting user testing with elderly individuals. Their feedback will be invaluable for further improvements. For increased accessibility, we are considering developing a dedicated mobile application that will have come across everyone, Android, iOS, and we even want to implement that in Windows OS, also Mac OS. Yeah. On the technical side, we recommend using a database like MongoDB for storing user chat IDs, which will improve our data management capabilities, and this will improve our sign in and sign up page. To enhance the system detection capabilities, we propose adding more sensors to detect human motion. Finally, we are exploring the integration of turning AI, artificial intelligence, and machine learning for object recognition, which could significantly improve the accuracy and capabilities of our security system. In conclusion, while we have made significant strides in creating a user-friendly IoT security system for elderly users, there is still room for growth and improvement. These recommendations will guide our next step as we continue to refine and enhance our product for you and for the community.